Welcome to the deep dive. Today we're cutting through some of the noise to explore something really compelling. It's right at the intersection of open source AI and, well, enterprise scale cloud power.
Hmm.
Our focus, Kortix Suna. It's this innovative open source generalist AI agent
Right.
designed to automate complex real world tasks just using natural language.
I
And it boasts some pretty impressive autonomy and a remarkable flexibility.
It really does.
So our mission on this deep dive is kind of threefold. First, let's really try to grasp Suna's powerful capabilities.
Okay.
Second, peek into its ingenious architecture, see what makes it tick.
Under the hood, yeah.
Exactly. And then here's where it gets really interesting. Understand how it can strategically integrate with Google's, extensive AI agent development kit, the ADK,
Indeed, a
and Vertex AI Agent Engine, and Google Agent Space.
whole ecosystem there.
Precisely. So this deep dive, it's your direct route to understanding how these powerful AI tools can combine, how you can forge custom, scalable, intelligent solutions for real-world problems. We want to offer insights that are, practical and forward-looking for anyone trying to navigate this AI landscape right now.
And what's particularly insightful here, I think, is that we're not just dissecting two separate technologies in isolation.
No.
We're really examining how the open source philosophy of Suna, its emphasis on transparency, on customization, how they can be amplified, maybe even supercharged by Google's comprehensive and secure cloud AI infrastructure.
Supercharged. I like
Yeah.
that.
And this begs a crucial question, doesn't it? How can developers, how can organizations strategically combine these, distinct strengths to build something far greater than the sum of its parts?
That's the key question.
It is. And our analysis today, just so you know, draws from a pretty detailed report. It meticulously covers Suna's architecture, its core functionalities, its presence on GitHub, and importantly, those specific strategic pathways for integration we were just talking about.
Okay, great. So let's really dive into Suna itself then. What exactly is this generalist AI agent we've been hearing about? What gives it this remarkable versatility?
Right. So at its essence, Suna is designed as a fully open source, general purpose AI agent. You can think of it as a highly capable digital companion, really.
Companion, okay.
Yeah, it's engineered to autonomously execute quite intricate, multi-step, real-world tasks. And the key is it does this based on your natural language instructions.
Just talking to it.
Pretty much. So whether you're grappling with, say, deep research, needing complex data analysis, or maybe just tackling various daily challenges, Suna's fundamental objective is to assist. And it achieves this by combining a really powerful suite of tools with an incredibly intuitive interface, one that's designed to truly comprehend your requirements and then deliver precise, actionable results.
Okay, so let's talk about that toolkit. You said it's extensive?
Oh, it's quite extensive and thoughtfully assembled, too. It includes things like seamless browser automation.
Okay, what does that mean exactly?
Well, Suna can effortlessly navigate the web, extract specific data points, perform repetitive online actions. Think about the time saved on tasks like, large-scale web scraping,
Oh, yeah.
or filling out forms over and over, or even just compiling market research from dozens of different sites. It likely uses robust browser control frameworks, something like Playwright, under the hood for that.
Makes sense.
But its capabilities extend far beyond just web interactions. Suna also offers comprehensive file management functionalities,
Like creating files.
creating, editing, organizing them, even generating content within them. Need a report drafted and automatically organized into a specific folder structure, Suna can potentially handle that.
Wow.
Its toolkit even extends to advanced web crawling and enhanced search capabilities. It might integrate with services like Tavily, for example, for highly targeted and relevant information retrieval, much better than what a typical search engine might give you.
So deeper searching.
Exactly.
Yeah.
Furthermore, Suna can perform command line execution for system tasks.
Okay, that's powerful.
It is. It gives it a deeper level of interaction with the environment it's running in. It can even facilitate website deployment, potentially from start to finish, and integrate with a wide array of third-party APIs and external services. That makes it a true hub for digital operations.
That is an extensive list.
It is, but it's important to understand the true power doesn't just come from the sheer number of tools it has access to.
Yeah.
The real revelation, I think, lies in the AI's sophisticated capacity to intelligently select and sequence these diverse tools in an appropriate and dynamic manner directly in response to your natural language requests.
Okay, so it's not just run tool A, then tool B.
No, not at all. This goes far beyond simple function calling. where an AI might just execute a predefined command or a single tool. Suna's comprehensive suite of functionalities positions it as a highly adaptable solution for automating multifaceted, often unpredictable workflows.
Unpredictable.
Yeah, because it isn't just about performing a task you've told it exactly how to do. It's about understanding the intent behind the task, even if that requires a sequence of actions or tool combinations it hasn't seen before.
That makes a lot of sense. So this distinction as a generalist AI agent, that really sounds like a significant architectural advantage then. How does that set it apart?
Precisely. Unlike more specialized AI tools, which might excel only in a narrow domain like, say, an agent focused just on browser automation.
Right, a one-trick pony.
Kind of, yeah. Suna's design implies a much more advanced cognitive framework. This framework allows the underlying large language model, the LLM, to orchestrate a diverse set of tools.
Okay.
This means it can seamlessly pivot from, say, browser interactions to file operations, then maybe to command line executions, and finally to API calls, all within a single complex workflow.
Wow, knitting it all together.
Exactly. It's not just executing one function. It's dynamically stitching together multiple disparate capabilities. This multimodal capability lets Suna understand broader context and automate complex, multi-stage workflows that would normally need human intervention or maybe multiple specialized bots working together.
I see.
And this level of dynamic orchestration, that's fundamental to Suna's high levels of autonomy and flexibility. It empowers the agent to interpret high-level user goals.
Just from plain English.
Yep. Decompose them into smaller, manageable subtasks, identify the best tools for each subtask, execute them, observe the outcomes, and then iteratively refine its plan if needed.
Like a digital MacGyver, you said?
Yeah. Yeah, something like that. Always finding the right solution from its extensive toolkit, even for tasks that it hasn't explicitly been trained on. This adaptability to unforeseen or novel tasks is a critical differentiator in the rapidly evolving landscape of AI agents.
Definitely.
And if we place this in a broader context, Suna's design, it fundamentally aims at bridging that gap between nuanced human intent and precise digital execution.
Intent versus action.
Exactly. This isn't just automation. It's about interpreting complex, sometimes vague human instructions and translating them into a precise series of digital actions. This needs advanced NLP, obviously, for intent recognition, robust planning capabilities to break down goals, and that dynamic tool unification we talked about to interact seamlessly with the digital world. The ability to bridge this gap signifies a truly intuitive interaction model, where you, the user, can express your needs naturally without needing technical knowledge of all the underlying commands or processes.
That's the dream, right?
It is. And Suna's operational prowess, it's underpinned by several key features that contribute directly to its real-world utility. Its natural language processing, as we said, lets you engage conversationally. No complex, rigid commands needed.
Makes it accessible.
Very much so.
Yeah.
The browser automation feature, that's a game changer. Navigating websites, extracting data, interacting with web elements, it streamlines tasks like market research, competitor analysis, large-scale data scraping with remarkable efficiency.
I can see that being huge.
Oh, absolutely. Then for analytical tasks, Suna offers powerful data analysis capabilities. Think summarizing dense scientific papers, sifting through huge data sets, generating comprehensive reports, directly supporting informed decision-making.
So it's not just doing, it's analyzing too.
Exactly. Efficient file management is another core feature. Automated creation, organization, manipulation of documents, spreadsheets, other files that can dramatically enhance administrative efficiency and just general digital hygiene.
We could all use some of that.
Couldn't we just? And finally, its robust API integration allows seamless connection with various external APIs. This extends Suna's functionality almost infinitely, enabling highly customized workflows tailored to your specific needs, whether it's integrating with a CRM, a project management tool, maybe a financial system.
The possibilities seem vast.
They really are. And the versatility is genuinely well illustrated through its diverse real-world applications across different sectors.
Like what? Give us some concrete examples.
Sure. For businesses, for instance, it can perform comprehensive market analysis, autonomously conducting competitor research, gathering industry trends, generating detailed reports to inform strategic decisions.
Okay, that's valuable.
Hugely. In human resources, Suna can provide invaluable recruitment assistance, scraping professional networks like LinkedIn to identify potential candidates, compiling relevant experience and contact info, maybe even initiating some preliminary outreach.
Automating the grunt work of recruiting.
Precisely. For personal or business travel, it can assist with travel planning. organizing comprehensive itineraries, flights, hotels, activities, all based on your preferences and budget.
Takes the headache out of planning.
Absolutely.
Yeah.
Furthermore, Suna is perfectly capable of SEO optimization, analyzing website performance against various metrics, identifying keyword opportunities, providing actionable insights to significantly improve search engine rankings.
Wow. So a small business owner could use this.
Exactly. Imagine that owner who can now automate their SEO analysis without needing to hire an expensive specialist. That's the kind of direct impact Suna can have.
Those applications are truly impressive. They really showcase its breadth. But I'm curious, given this incredible power and versatility, what's a fundamental thinking, the philosophy that guides Suna's development? And maybe more practically, how accessible is it for someone to actually start using it?
That's a crucial question. Kortix Suna is really distinguished by its unwavering commitment to being 100% open source. It's built on core principles of transparency and collaborative innovation, and it's released under the permissive Apache 2.0 license, which means profound accountability. It fosters continuous innovation from a global community, and it actively encourages collaboration. For you, as a potential user or developer, this means you can explore its inner workings, you can contribute to its ongoing development, or even fork the repository to customize the agent for your specific, unique requirements.
That level of control is rare.
It is. It's a level of control and insight you rarely get with proprietary closed-source solutions.
And beyond the philosophy, what about the practicalities? Getting it up and running. Deployment flexibility is always key for our audience.
Absolutely. And the deployment flexibility of Suna is a key advantage. It offers both cloud-based usage through Kortix AI's own managed services and robust self-hosting options.
Okay, tell me about self-hosting. Is it complicated?
Well, they tried to make it easier. For those opting for self-hosting, there's a comprehensive setup wizard. You initiate it just by running python setup.py from the command line.
Ah, script.
Nice. Yeah, it guides you through configuring the essential components. This includes setting up a Supabase project for the database and authentication.
We'll get more into Supabase later, I assume.
We will.
Yeah.
It also involves setting up Redis for efficient caching and session management that keeps things running smoothly, and integrating Daytona for secure, isolated agent execution environments.
Daytona, another component.
Yes, specifically for managing those secure containers we'll discuss. Furthermore, the wizard facilitates seamless integration with various large language model providers, Anthropic, OpenAI, OpenReader, leveraging the Little LM library for this.
Little LM, okay. That sounds important for flexibility.
It is, very. And there are optional configurations too. You can add advanced capabilities like web search and scraping via services like Tavily or Firecrawl, and even background job processing and workflow management through something called QStash. So it's highly customizable and robust for deployment.
Okay, so it's open source, flexible to deploy. But how does Kortix AI, the company, sustain this project? What's the business model supporting this? Is it just volunteer-driven?
That's a fair question. Suna's business model strategically combines its open source nature with what's often called a freemium layer.
Freemium, okay.
Right. While the core Suna agent is 100% open source and freely available for anyone to use and modify.
The core is free.
The core is free. Kortix AI also provides paid plans. These plans offer additional benefits, like AI token credits, which you need for accessing premium, often larger and more powerful, AI models and priority support, mainly geared towards enterprise users or those needing dedicated assistance.
So they monetize the usage and support.
Exactly. This approach intelligently leverages community contributions for accelerated development and builds trust through that open source transparency. But simultaneously, it monetizes the consumption of those expensive underlying LLM resources, which can be a significant cost for advanced AI agents, and offers enhanced dedicated support services. It's actually a very smart and, I think, sustainable way to ensure the long-term viability and continuous improvement of an open source project like this. Balances community access with commercial reality.
That is a great approach to sustainability, but it raises a point you hinted at earlier. While Suna's core logic is open source, its operational robustness, especially for self-hosting, seems to rely heavily on external infrastructure components. Does that introduce any potential bottlenecks or complexities for users who aren't, say, fully cloud native? How robust is that dependency chain on things like Supabase, Redis, Daytona?
That's a crucial consideration, and you've definitely hit on an important nuance there. While Suna's core logic is indeed open source, its operational robustness, particularly for self-hosting, does rely on external infrastructure components.
Right.
The self-hosting guide clearly reveals a notable reliance on established services like Supabase for its PostgreSQL database and authentication,
Okay.
Redis for caching, and Daytona for those isolated agent execution environments.
So it's not completely standalone.
No, exactly. This means that Suna, while open source at its core, isn't a completely self-contained solution out of the box for self-hosting. For you, the user, this implies needing to manage and provision these external dependencies yourself.
Which could be a hurdle for some.
It could be. But what's truly insightful here, I think, is that this design choice allows Kortix AI to leverage battle-tested high-performance services. They don't have to reinvent the wheel for databases or secure execution environments, which significantly simplifies their core development efforts.
Focuses their energy.
Right. However, as you point out, it can introduce a layer of complexity for those less familiar with cloud infrastructure, database administration, or maybe Docker orchestration. It's a trade-off, isn't it?
Yeah.
Immense power and modularity, but with the expectation of some familiarity with modern infrastructure stacks if you want to do full self-hosting.
That's a very clear explanation of the trade-offs. So knowing that, let's pull back the curtain even further. Let's look at how Suna is actually built. What's truly under the hood of this modular masterpiece you mentioned?
Okay, let's get into the nuts and bolts.
Yeah.
Suna is engineered with a profoundly modular architecture. It comprises 4 primary components that operate in concert.
4 main parts.
Yeah. Think of Suna's internal structure like a modern city, maybe, not a single monolithic building. Imagine different specialized districts.
Okay, I like that analogy.
You've got a back-end API, a front-end, an agent Docker environment, and a Supabase database. This clear demarcation of components into distinct services, back-end, front-end, agent Docker, Supabase, is truly indicative of a microservices-oriented architecture.
Microservices. Got it.
And this design pattern inherently supports the independent deployment and scaling of each service. For instance, the backend can be scaled up or down independently of the front end, based purely on API load.
Right.
Or multiple agent Docker instances can run concurrently to handle parallel agent tasks without affecting the UI. This distinct separation of concerns, it's a deliberate design choice offering compelling advantages.
Such as?
Well, independent scalability of each component, as I mentioned. Simplified maintenance, you're fixing one part, not risking the whole system. And the flexibility to utilize specialized technologies best suited for each functional area.
Right, tool for the job.
Exactly. Yeah. So for you, this means Suna can scale efficiently, updates to one part are less likely to break the whole system, and it's generally far more resilient to failures.
Okay, maybe give us a quick rundown of those 4 components before we dive deeper.
Sure. So the backend API that's built with Python and FastAPI. It handles all the core logic, the crucial LLM integration, and the agent orchestration, the decision-making.
The brains.
It's essentially yes. The front end, using Next.js and React, provides that responsive user interface, the chat window, the dashboard we talked about earlier.
The face.
The face, good one. The agent Docker, powered by Docker and Daytona, creates that isolated and secure execution environment for every agent task. That includes the browser automation, code interpretation, file access.
The secure sandbox.
Perfect.
Yeah.
And finally, the Supabase database, built on PostgreSQL, manages all the data persistence, user accounts, conversation history, files, state, everything.
The memory.
The memory and the record keeping. Each component plays a vital, specialized role. So, shall we dive deeper into each one?
Let's start with the backend API, the brains.
Right. Developed in Python using the FastAPI framework, this functions as the central logic and orchestration hub for the entire Suna system. Its responsibilities are multifaceted, it handles all the REST endpoints, manages concurrent threads to keep things responsive, and critically integrates with various large language models through that library we mentioned, LitLLM.
Tell me more about LitLLM. Why is that so important?
Well, the brilliance here is that LitLLM acts as a vital abstraction layer. It enables flexible integration with diverse LLM providers, Anthropic, OpenAI, OpenRouter, potentially others in the future, without requiring significant changes to Suna's core code.
So you can swap out the LLM easily.
Right. Relatively easily, yes. This strategically future-proofs Suna against potential shifts in LLM pricing or availability, or even the emergence of new, superior models. It ensures adaptability and longevity in this incredibly fast-moving AI landscape. It's like a strategic shield, allowing Suna to pivot to the best or most cost-effective LLM without breaking its core functionality.
That's smart planning.
Very. This core backend component, it's responsible for processing your incoming user requests, maintaining the state of ongoing conversations across interactions, remembering the context.
Crucial for conversation.
Absolutely. And intelligently orchestrated the agent's tool usage, determining which capabilities to invoke at any given moment. All communication with whichever LLM you've chosen is facilitated through this backend service.
Okay.
And the central logic file within this component, it's also critical for handling environment-specific configurations. Things like secure connections, adapting to different development versus deployment environments. This shows a robust approach to API security and flexible configuration, which is essential for a distributed system talking to multiple components and external dependencies.
Right. Things can get messy otherwise.
They can. And the very nature of network and connection errors sometimes reported in discussions around this component, it just underscores the need for sophisticated configuration management and error handling within this backend to ensure the whole system remains stable and reliable.
So zooming out again, this backend is really the heart of it all.
Unquestionably. If we connect this to the bigger picture, the backend's comprehensive responsibilities, thread management, LLM integration, conversation state, tool orchestration, unequivocally establish it as Suna's central computational core.
Where the thinking happens.
Precisely. This implies that the complex decision-making processes, the strategic planning, the execution flow of the AI agent, it primarily resides within this Python Fast API service. It's where the LLM's reasoning is applied to interpret your input, where the agent's internal state conversation history, current task context is meticulously managed, and where those critical decisions about tool selection and sequencing are made and executed. The front end is just the interface. The agent Docker is the sandbox, but the back end. That's where Suna's intelligence and agency truly manifest and drive the action.
Okay, clear. Let's move to the front end, then the face.
Right. So the front-end component of Kortix Suna, it's implemented as a Next.js React application. It's meticulously designed to deliver a responsive UI, including that dynamic chat interface and a comprehensive dashboard.
The part the user actually sees and interacts with?
Exactly. This component serves as the primary point of interaction. It lets users converse naturally with Suna, submit complex tasks, and monitor the progress and outcomes of agent activities in real time. For you, the user, this translates to an intuitive and approachable interaction, hopefully removing any technical barriers.
And the choice of tech, Next.js React.
Well, the selection of Next.js React, coupled with that emphasis we saw on an intuitive interface and a chat interface, it really highlights a strong focus on user experience.
Which is key for adoption.
Absolutely paramount. For a generalist AI agent like Suna aiming to bridge human intent and digital execution, a user-friendly and engaging interface is critical. Complex capabilities must be accessible through simple conversational interactions to ensure broad adoption and ease of use. The choice of these modern web technologies supports creating a smooth, interactive, highly responsive experience, essential for enabling users to initiate and manage complex tasks through natural language without being overwhelmed by the underlying technical complexities.
Makes sense. Okay, next up, the agent Docker component, the secure sandbox.
Yes, the agent Docker. This is a critical element of Suna's architecture. It provides an isolated execution environment for every single agent task.
Every task gets its own sandbox.
Every task. Think of it like a completely secure, isolated playpen for each thing Suna does. Just like you'd put a child in a playpen to keep them safe and prevent them from, messing up the whole house.
Ah, good analogy.
This sandbox ensures that Suna's actions, whether it's browsing the web, running complex code, interacting with files, are strictly confined. This sandbox container, it's expertly managed by that Daytona tool we mentioned earlier.
Right, Daytona manages these.
Correct. It encapsulates all the necessary capabilities for agent operations. Robust browser automation, likely Playwright again, a secure code interpreter for running dynamically generated code safely, controlled file system access within the sandbox, and seamless integration with various tools. This strict isolation is absolutely fundamental to the system's integrity.
How so?
Well, it prevents agents from inadvertently interfering with each other, or worse, maliciously compromising the host system they're running on.
That brings up a vital point, right? Security and reproducibility, especially with command line access and file system access.
Exactly. When an AI agent is empowered with capabilities like command line execution and file system access, the potential for security vulnerabilities or just unintended system modifications becomes a significant concern.
Definitely.
By running each agent task within its own ephemeral Docker container, meaning it's temporary, spun up for the task, and then destroyed, Suna effectively confines any actions taken by the agent to that isolated sandbox. It mitigates the risk significantly. If something goes wrong, it stays contained within that temporary environment, never affecting your main system or other agent tasks.
That's reassuring. And reproducibility.
It helps usually there too. This containerization contributes significantly to reproducibility because the execution environment for each task is standardized. It's the same every time. This helps eliminate those frustrating, well, it works on my machine issues across different deployment scenarios.
We've all been there.
Haven't we just? And the integration with Daytona further underscores a commitment to a robust, specialized solution for orchestrating and securing these agent execution environments. It makes it a much more reliable choice for production use cases where stability and security are paramount.
Okay, excellent. And the final piece of the puzzle, the Supabase database, the memory.
Right. Supabase, which is a powerful platform built on top of PostgreSQL, is integral to Suna's architecture. It handles all the data persistence requirements for the project.
All the data storage needs.
Pretty much everything. This comprehensive database solution is responsible for managing crucial aspects like user accounts and authentication, ensuring secure access for you, maintaining a detailed history of conversations, providing secure storage for files generated by the agent during its operations, meticulously tracking the agent's internal state, and supporting things like analytics and real-time subscriptions for dynamic data updates.
So why Supabase? Why not just run a standard PostgreSQL database?
Well, what's insightful here is the strategic decision to leverage a managed backend as a service, or BOSS, like Supabase. This significantly accelerates development cycles because it offloads common but complex functionalities, user management, real-time updates, data storage APIs, to a specialized, often managed service.
So Kortix doesn't have to build all that plumbing.
Exactly. It also provides built-in scalability and robust security features, reducing the operational overhead for the Kortix AI team, and also for you if you're opting for self-hosting with Supabase's managed tier. This allows the core engineering resources to be focused laser-sharp on the unique, differentiating AI agent logic, while benefiting from a robust, scalable, and secure data layer without requiring extensive database administration expertise.
An efficient division of labor.
Precisely, ensuring the project can focus on its AI strengths.
That's a fantastic, comprehensive look under the hood. Knowing how it's built and the philosophy behind it, let's kick into its open source home now, the GitHub repository. How is it organized? And what does that organization tell us about Kortix AI's approach to open source development and maybe community engagement?
Right, the GitHub repo. You can find it easily at https://github.com/Kortix AI Suna. And it is meticulously organized. This structure directly reflects that modular architecture we just discussed.
Makes sense.
And it's clearly designed to facilitate both their internal development and, crucially, external community contributions. The overall structure provides a very clear separation of concerns, making it pretty accessible for new users or contributors to jump in, and efficient for ongoing development. It's like a well-labeled library for code, as you said earlier.
So walk us through some key directories. What would we find?
Okay. You'll find a .github workflows directory. As you might expect, that contains GitHub Actions workflows. These are absolutely essential for CI/CD continuous integration, automated testing, deployment, other automated tasks, all ensuring code quality and efficient release management.
Standard good practice.
Definitely. There's a .vscode directory, which typically houses configuration files specific to Visual Studio Code, helping to streamline the development environment for contributors who prefer using that popular IDE.
Helpful for developers.
The backend directory, as we discussed, contains the entire source code for that Python Fast API service, the intelligent core, the decision-making engine.
Got it.
The docs folder is dedicated to comprehensive documentation. You'll find important assets there like detailed architecture diagrams, providing both visual and textual explanations of Suna's sophisticated design.
Documentation is key.
Crucial for open source. The front-end directory houses the source code for the Next.js React user interface, the part you actually interact with. And finally, the agent Docker directory contains components related to that isolated agent execution environment, fundamental to Suna's operational model and security.
Okay, that covers the main code areas. Beyond the directories, what about some of the main configuration files or entry points that help users get started or understand the core structure?
Good question. Some main configuration and entry point files are strategically placed right at the root to simplify setup and operation. The readme.md file, that's your primary entry point for understanding the repository. It offers a comprehensive overview of Suna, its capabilities, its architecture, typical use cases, and importantly, detailed step-by-step instructions for self-hosting.
Start here.
Definitely start there. The licensee file explicitly states that Kortix Suna is licensed under Apache 2.0, clearly defining the open source terms for use and contribution.
Clear licensing, good.
Very important. The docker-compose.yaml file. This is crucial for defining and running multi-container Docker applications. It orchestrates the various interconnected components of Suna, the backend, front-end, database dependencies, etc., to significantly simplify the overall deployment process, especially locally.
Makes setup easier.
Much easier. Then there's that setup.py Python script we mentioned. That serves as the intuitive entry point for the self-hosting setup wizard, making local deployment far more accessible than manually configuring everything.
The guided setup.
Exactly. And start.py is a little utility script designed for conveniently starting or stopping the Docker containers once they're configured. What's really insightful here, looking at all this, is a clear emphasis on developer experience and ease of onboarding. It's evident in these user-friendly scripts and the comprehensive documentation. This is absolutely crucial for fostering community growth and widespread adoption of any open source project, especially one as potentially powerful and complex as Suna.
That's a fantastic overview of its structure. Building on that, let's maybe look at a specific example within that backend code that truly exemplifies Suna's core logic. You mentioned a central file, api.py. What makes that file so significant?
Right, backend.py.py. This file really stands out as a central component within that Python fast.py service. You could call it the nerve center. It's responsible for handling all incoming user requests through its REST endpoints, facilitating that crucial LLM integration via LeetLM, and orchestrating the complex operational logic of the agent itself.
So requests come in here, decisions get made here.
Largely, yes. This file is specifically tasked with managing those incoming user requests, maintaining the conversational state throughout interactions, and intelligently coordinating the agent's tool usage, deciding which tools to invoke based on the user's intent. It's where Suna decides what to do next.
Okay.
And discussions and issues filed against api.py on GitHub further highlight its critical role in managing environment-specific configurations. For instance, this file incorporates logic for conditional database initialization.
What does that mean?
Well, it includes mechanisms for streamlined local development setups, allowing developers to, say, skip full database provisioning sometimes, just to get Suna running quickly for testing specific parts.
Ah, developer convenience.
Exactly. Furthermore, api.py is deeply involved in cross-origin resource sharing, or CORS configurations. These are essential for web security when different parts of an application, like the front end and back end, communicate across different domains or ports.
Security built in.
Well, the configurations for it, yes. These details underscore a design philosophy that prioritizes robust handling of API security and adaptable environment settings, which are absolutely essential for a distributed system interacting with multiple components and external dependencies like LLMs, Supabase, Daytona, and so on. The occurrence of network and connection errors, sometimes reported in various issues, just underscores the necessity for sophisticated configuration management and error handling within this back-end component to ensure the whole system remains stable and reliable. It truly is the workhorse behind the entire operation, where Suna's intelligence translates into planned action.
Okay, that makes perfect sense. This brings us then to the really exciting culmination of our deep dive. How can Suna, with its powerful open source foundation, strategically play nicely with Google's extensive AI agent ecosystem?
Right, the integration piece.
Yeah. The report suggests significant opportunities for synergy, even though, as you said, they're distinct platforms. So what does this all mean for you, the individual or organization, when it comes to building even more powerful custom AI solutions? Are we talking about like a complete merge, or is it more of a strategic partnership?
That's a fantastic way to put it. It's definitely more of a strategic partnership, leveraging Suna's unique strengths as a specialized tool or component within Google's broader framework.
Okay.
So while Kortix Suna and Google's AI agent ecosystem, including the ADK, Agent Engine, and Agent Space, are distinct platforms, Suna's open source nature and that modular design we hammered on present significant opportunities for strategic integration within a Google Cloud context. It's about finding the perfect adapter, maybe for two incredible machines.
An adapter, I like that. So let's break down the Google side. Start with the Google Agent Development Kit, ADK. What is it and how does Suna fit in?
Okay, ADK first. This is Google's open source framework, specifically designed to empower developers in building, managing, evaluating, and deploying AI-powered agents and sophisticated multi-agent systems.
Multi-agent systems, too.
Yes, that's a key strength. It's versatile enough for both conversational agents like chatbots and non-conversational agents that handle complex tasks and workflows behind the scenes.
What are the core concepts in ADK?
Well, core concepts within ADK include the agent itself. That's the fundamental worker unit.
Right.
You have things like an Elm agent for reasoning using a large language model, but also workflow agents like sequential agent, parallel agent, loop agent for more deterministic control over multi-step processes.
More predictable flows.
Exactly. Then there's the tool. This is how agents get abilities beyond just conversation. It lets them interact with external APIs, perform searches, execute code, connect with other services. ADK supports integrating your own custom functions using Function Tool, using other agents as tools with Agent Tool, and leveraging built-in functionalities like code execution. It also supports something called Model Context Protocol, or MCP, tools, and boasts over 100 pre-built connectors to various enterprise systems.
Wow, 100 plus connectors. That's extensive.
It is. ADK also excels in session management and memory, handling the context of a single conversation session, the agent's working memory state, and long-term recall memory across sessions to personalize interactions.
Remembering things long term.
Crucial. Planning is another advanced capability, letting agents break down complex goals into smaller, manageable steps, often using techniques like React.
React, okay.
And orchestration is incredibly flexible. You can use those workflow agents for predictable pipelines, or you can have LLM-driven dynamic routing for more adaptive, intelligent behavior. ADK particularly shines in multi-agent system design, enabling hierarchical structures and intelligent routing for complex coordination and delegation between agents.
Okay, ADK sounds incredibly robust, very comprehensive. So how does Suna, with its generalist capabilities, actually plug into that?
Right. What's truly compelling here is how Suna, with its generalist capabilities and that advanced tool orchestration we talked about, can be strategically integrated into an ADK-built multi-agent system.
How?
Imagine Suna's specialized functionalities, that seamless browser automation, the comprehensive file management, the command line execution being exposed as custom tools that are callable by ADK agents.
Suna becomes a tool for ADK.
Precisely. This would allow a higher-level ADK orchestrator agent, maybe one managing a complex research task, to delegate specific, intricate, real-world interaction tasks to Suna. Effectively, Suna becomes a powerful, specialized sub-agent or an advanced tool within that larger ADK framework.
Can you give an example?
Sure. An ADK agent tasked with, say, complete market analysis for product X could call upon Suna as a tool to perform the actual web scraping across competitor sites and industry reports, and maybe aggregate the raw data into a structured file. Then, Suna passes that clean data back to the ADK agent, which continues its analysis or generates the final report.
So ADK handles the high-level plan, Suna does the heavy lifting on the web and files.
That's a great way to put it. And the commonality of LitLM support, remember, Suna uses it for its LLM integration, and ADK supports a rich ecosystem of models, often via similar mechanisms that further facilitates this interoperability. It provides more consistent interface for LLM interactions across both frameworks, meaning less friction in getting them to talk effectively to each other.
Okay, that makes sense. Using Suna as a powerful, specialized tool within ADK. What about the next piece, Vertex AI Agent Engine?
Right, Vertex AI Agent Engine. This was formerly known as LangChain on Vertex AI, if people remember that name.
Oh, okay.
It's a comprehensive suite of managed services designed specifically for deploying, managing, and scaling AI agents in robust production environments. Its primary function is really to abstract away all the complex infrastructure management.
Takes care of the ops side.
Exactly. It allows developers to concentrate solely on the agent application development and its unique logic, not worry about servers, scaling, security patching, etc.
What kind of services does it offer?
Key services include a managed runtime. This provides capabilities for deploying and scaling agents, customizing the underlying container images if you need specific libraries, and incorporating crucial enterprise-grade security features like VPCSE compliance, proper authentication, and identity and access management, or IAM.
Security is built in.
Very much a focus. It also offers robust context management, providing sessions for storing individual interactions and a memory bank for that crucial long-term information retrieval, personalizing agent interactions over time. For quality assurance, it integrates with the Gen AI evaluation service and something called the Example Store to help you continuously monitor and improve agent performance.
Tools for making the agent better.
Right. And for transparency, it provides comprehensive observability through standard Google Cloud tools like Cloud Trace, Cloud Monitoring, and Cloud Logging. This lets you see exactly what your agent is doing, how it's performing, and troubleshoot issues effectively.
Okay, so this is really Google's answer for taking an agent from development to reliable production. How does an open source solution like Suna fit into that managed environment? Especially given its external dependencies like Supabase and Daytona we discussed earlier.
That brings up a crucial consideration, doesn't it? How do you take an open source solution like Suna with all its parts and deploy it robustly in a production environment?
Well, Suna's modular architecture, particularly its containerized backend API and agent Docker components, makes it actually incredibly well suited for deployment and management within Vertex AI Agent Engine.
How so?
Because Suna's backend, the Python Fast API part, and its isolated agent Docker environments can be easily packaged as standard container images, Docker containers.
Okay.
These images can then be deployed directly to Agent Engine's managed runtime. This approach would allow Suna to leverage Agent Engine's robust capabilities for production-grade deployments. Think automated scaling based on demand.
Handles traffic spikes automatically? Exactly. Enhanced security features like VPC service controls, which create a secure network perimeter around your services. And all those integrated observability tools for monitoring performance and behavior. By offloading these significant operational complexities, managing servers, scaling, security patching, monitoring infrastructure to Agent Engine, developers can focus entirely on refining Suna's core agent logic and capabilities without getting bogged down in the infrastructure weeds.
So it's a powerful way to bring that open source agility of Suna to enterprise scale reliability using Google's managed infrastructure.
Precisely. It's a very practical path to production for Suna within the Google Cloud ecosystem.
Okay, one more Google component, Google Agent Space. What's the story there?
Right, Google Agent Space. This is really an enterprise-focused search and AI agent hub. It's designed to enhance productivity by connecting all your disparate work applications with Google quality multimodal search and the power of AI agents all in one place.
So a central hub for employees.
Exactly. It enables users to quickly find information across their business's internal systems. Think Confluence, Drive, Jira, SharePoint, ServiceNow. Summarize and synthesize data from all these various sources, and then take action using pre-built or custom AI agents. And crucially, it does all this while adhering to stringent enterprise-grade security, privacy, and compliance standards.
What are its key features?
Key features include that enterprise search. It connects to all those popular applications I mentioned, providing multimodal search. It understands not just text, but also images, charts, video, audio found within your enterprise data.
Searches everything.
Pretty much.
Yeah.
It also offers content generation, utilizing Google's powerful Gemini models to summarize, generate, and act on that enterprise data, producing high-quality content like text summaries, charts, tables, even audio or video snippets sometimes.
Generate content based on internal data?
Yes. Automation enables common tasks and multi-step workflows across various business functions, often initiated from search results or conversations. Custom agents serve as a centralized launch point for bespoke AI agents, like potentially one powered by Suna, that apply generative AI contextually. It provides a unified interface for employees to discover and access these specialized expert agents.
A single place to find all the company's agents.
Exactly. And critically, it ensures security and privacy. Built on Google Cloud's Secure by Design infrastructure, it offers granular IT controls, robust role-based access control, RBAC, VPC service controls, and seamless IAM integration. Data stays within your defined boundaries.
Okay, so what does this all mean for you in a large enterprise setting? It sounds like the ultimate front door for accessing all these AI capabilities, including potentially Suna.
Exactly right. Once Suna-powered solutions are robustly deployed and managed via Vertex AI Agent Engine, as we just discussed, they can then be exposed or integrated into Google Agent Space as custom agents.
Ah, so Suna appears inside Agent Space.
Correct. This integration would allow enterprise users to access Suna's specialized automation and data analysis capabilities. Remember, market analysis, recruitment assistance, SEO optimization, through Agent Space's unified, secure, and user-friendly interface.
So employees don't need to know about Suna directly.
Not necessarily. Instead of needing to know how to deploy Suna or even how to craft complex prompts specifically for it, employees could simply interact with the market analysis agent or the recruitment helper agent powered by Suna under the hood, right within their familiar Agent Space environment.
Seamless integration.
That's the goal. By connecting Suna to Agent Space, organizations can leverage Agent Space's extensive data connectivity across various enterprise applications and its powerful multimodal search capabilities. This allows Suna to operate on a broader and more secure dataset within the corporate environment, all without that sensitive data ever leaving the secure enterprise boundary. This positions Suna as an incredibly valuable, specialized agent within a larger, governed enterprise AI ecosystem. It enables employees to accomplish complex tasks that require planning, research, content generation, and actions through potentially a single, intuitive prompt within agent space. It's really a way to democratize Suna's power across an entire organization, safely and effectively.
That's a truly fascinating convergence. Open source agility meeting enterprise-grade infrastructure and accessibility. Okay, let's try and bring it all together one last time. We've seen that Kortix Suna is this highly capable, flexible, open source, generalist AI agent. It's distinguished by its modular architecture, its robust toolkit for real-world automation, its ability to interpret natural language, orchestrate diverse tools, browser automation, file management, command line, API integrations, and operate within those isolated, secure environments truly makes it a powerful asset. And its open source model, coupled with that smart freemium layer, it really speaks volumes about its potential sustainability and widespread adoption.
And zooming out, what this means, I think, is that Suna's architectural design, that modularity and its reliance on established battle-tested technologies like Docker, Python, potentially Supabase, they create very clear and practical pathways for integration with Google's comprehensive AI agent ecosystem.
Right.
The commonality of using things like LiteLM for LLM integration flexibility and the containerized nature of Suna's core components. These are significant enablers for interoperability. It makes it a really compelling proposition for developers and organizations looking to build cutting-edge AI solutions that leverage both open-source innovation and enterprise cloud power.
So, based on this whole analysis, what are the key recommendations for someone listening? How should they think about leveraging Suna within that Google AI framework?
Okay, based on our analysis, we have several key recommendations. First, strongly consider Suna as a specialized tool within Google ADK.
Use its strengths.
Exactly. Maximize the strengths of both platforms. Have ADK orchestrate the complex, perhaps multi-agent workflows, while Suna handles the deep environmental interaction. Expose Suna's robust browser automation, file management, command line capabilities as callable functions or subagents within ADK.
Okay, recommendation 1.
Second, for reliable, scalable operations, actively pursue production deployment via Vertex AI Agent Engine.
Take it to production properly.
Yes. This transforms Suna from maybe a development prototype into a true production-grade service. Leverage Google Cloud's unparalleled infrastructure for automated scalability, enhanced security like VPC service controls, and integrated observability. Don't try to reinvent that wheel.
Makes sense. Third,
for maximum enterprise accessibility and impact, ensure enterprise exposure through Google Agent Space. This highlights the immense value of providing centralized, secure access to Suna's powerful capabilities for your enterprise users, leveraging Agent Space's data connectivity and multimodal search within their familiar workflow.
put it where the users are.
Precisely. Fourth, continue the strategic use of LiteLM for LLM flexibility within Suna's architecture, whether you integrate it with Google or not. This is absolutely crucial for maintaining adaptability to future LLM advancements, pricing shifts, or specific model requirements. It aligns perfectly with ADK's native support for diverse models too.
Keep your options open.
Always. And finally, a call to action, really. Strongly encourage community contribution for enhanced interoperability. For developers out there engaged with both Suna and Google's AI ecosystem, actively contributing back to Suna's open source project can foster further compatibility, maybe even direct integrations or connectors with Google's components. This leads to an even more seamless and powerful combined platform that benefits everyone in the community.
Great recommendations. So here's where it really gets compelling. Maybe a final thought for you, our listener. Consider not just using these tools as they are presented, but actively thinking about how open source innovation, like Kortix Suna, can increasingly serve as the agile, specialized hands and feet of larger managed enterprise AI systems.
The hands and feet?
Yeah. This convergence creates a truly hybrid future where the best of both worlds, the transparency and customization of open source, and the scale and security of enterprise cloud can genuinely converge. So, the question for you is, what complex task, perhaps one you thought was impossible to automate until now, could you tackle with this kind of combined power?
Food for thought.
Definitely. That's it for this deep dive. We hope you're leaving with a clearer, richer understanding of Kortix Suna and the incredible potential it unlocks when strategically paired with Google's comprehensive AI agent ecosystem. We've truly tried to unpack what it means to build powerful, custom, intelligent AI solutions for the real world today. Thanks for joining us.
Thanks, everyone.
This has been The Deep Dive.